welcome back. We are solving the pending problems. Day 14 and 15 today. Day 14 parabolic reflector dish. This is made of small mirrors, but while the mirrors themselves are roughly in the shape of a parabolic reflector dish, each individual mirror seems to be pointing in slightly the wrong direction. The dish is meant to focus light. All it's doing right now is sending it in a vague direction. The system must be what provides the energy for the lava. If you focus the reflector dish, maybe you can go where it's pointing and use the light to fix the lava production. Upon closer inspection, the individual mirrors each appear to be connected via an elaborate system of ropes and pulleys to a large metal platform below the dish. The platform is covered in large rocks of various shapes. Depending on the position, the weight of the rocks deforms the platform, and the shape of the platform controls which ropes move and ultimately the focus of the dish. In short, if you move the rocks, you can focus the dish. The platform even has a control panel on the side that lets you tilt in one of the four directions. The rounded rocks will roll when the platform is tilted, while the cube-shaped rocks will stay in place. You rotate the positions of all the empty spaces. You note the positions of all the empty spaces and rocks. For example, this is the input. Start by tilting the lever so all the rocks will slide north as far as they will go. Okay, as far as north until a hashtag is reached, right? So okay, understood. You notice that the support beams along the north side of the platform are damaged. To ensure the platform doesn't collapse, you should calculate the total load on the north support beams. The amount of load was single and was equal to the number of rows from the rock to the south edge of the platform, including the row the rock is on. Cube-shaped rock don't contribute to the load. Okay, the amount of load caused by each rock in row is as follows. In each row, this is 10. The amount of load caused by a single row, this is equal to the number of rows from the rock to the south edge of the platform. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, like this, to the south edge of the platform, including the row the rock is on. Why is it 1 here? The amount of load was a single rounded rock. Each rock in each row. Rounded and cube shaped. So first of all, this will happen, and after that, this is I guess a row number and not necessarily the load cost. Or is it? The total load is the sum of load cost by all of the rounded rocks. In this example, the total load is 136. I hope this is not the sum of first and numbers, I guess. Okay. The amount of load caused by a single rock is equal to the number of rows from the rock to the south edge of the platform. I hope this is the south edge. And we only check the round rock, round shaped. These don't contribute, so there are okay. What is this load close by? I want to check whether this one, how this 136 is formed. Sorry. This should be. I was thinking that from this to the last round block to the south, but that's not the case. We just need to count the number of rows. So this has number of rows equals to 10, right below it. So there are 5 of them in the 10th row, so 5 times 10 plus 2 times 8 plus 4 times 8, likewise we need to find out the sum. Okay, that's understood. I misread the problem statement at first. What is the total? Okay, first of all we need to do this, then we will find out the actual answer. Fine, we will just go column by column and then get it. Let's take the input. AOC 2023 create D14. Let's go over the implementation. Take in the input. Input is done. Let's initialize rows and columns. Then I will go over all the columns and get the contribution for each of them individually. So for all the columns, M columns, I will, let me also enable screen key. I forgot to do that today. Fine. For the rows in 1 to n, the column would be this value. Let's create a copy of that at of row of call, and let's say the final answer is added with the contribution for this column, right? Let me initialize answer and print the answer. Next, let's write contribution. Let's take it a string. Let's make it S. I'm reading it from top to bottom. So What I will do is I will start reading from this first index. So this from left to right in this string means top to bottom in this particular column. And whenever I encounter a hash, that's when I will rearrange these values. And I just need to store the counts of dots and capital O's. So hash is the blocker, and everything in this in between two hashes is rearranged. So let's say C0 is the count of O's and C hash. Is it allowed? No. Let's say C1, and let's create a new string for storing the rearranged column character in S. If ch is a hashtag, then we need to do one thing. We need to put all the zeros first. So while c0 is greater than 0, we add this capital O, and for these many we add a dot, and after that I also need to add a hashtag. Okay, not here. After that, if it is not, then I just need to increment the count for them. So c0 is ch is capital O, and this means it is a dot. I hope this works, and let's say for this case this row, until this row would be initialized, but after this we may have some of the c0s and c1 pending. So let me just paste this code here, which will take care of that. Okay, fine. Now we will have this particular thing, and for each row from left to right I just need to add the value of n minus row id for zero based. Yes. So let's see. Answer for this particular column. I'm making too many typos today. I hope it will be of size is equals to number of rows. If it is a capital O, then answer plus equals to n minus I. Fine, let's run it. Did we do anything wrong? Stuck, maybe. This looks fine. Here I will go over all the columns. Contribution. After this should be initialized with 0, because this may become negative and while of a negative value is or true. Perfect. So let's try it on the last test case. /sol on test. Submit. Right, let's move on to part 2. Let me take a backup before that. and refactor the first part solution. I don't think there is anything to refactor. Let's copy .cpp soul, sorry, copy soul part 1 done. Part 2, the parabolic reflector deforms, but not in a way that focuses the beam. To do that, you will need to move the rocks to the edges of the platform. Fortunately, a button on the side of the control panel labeled spin cycle attempts to do just that. Each cycle tilts the platform 4 times so that the rounded rocks roll north, then west, then south, then east. After each tilt, the rounded rocks roll as far as they can before this first part was this, that all the rounded blocks go north, and after each tilt the rounded rock goes as far as then before the platform tilts in the next. Okay, this tilt will happen and all the rounded will go in their respective position. Then from there they will go to their respective position in those 4 other directions. After one cycle, the platform will have finished rolling the rounded rocks in those 4 directions in that order. Here's what happens in the example above after each of the first few cycles. This process should work if you leave it running long enough, but you are still worried about the north support beams. To make sure they'll survive for a while, you need to calculate the total load on the north support beams after these many cycles. In the above example, okay. Obviously, this is not feasible to simulate, so we need to think of some clever approach. One cycle will transform. Let's try to analyze this a little bit. Copy in one to check. This was after the first cycle, right? So first, let's only look at the top left stone or block. This O in the first tilt remained in its own position. In the second one, I mean, what is the direction of this tilts? North, west, south, and east. North, then okay, in anti-clockwise. Okay, fine. So north, then west. It will remain in the same position. Then south means it will go somewhere here. It will go. This will go here. This will go here. It will come here, and after that, it is pushed to the east. That means to the right. Here. Okay, fine. So we can know in one particular iteration, in one cycle, it will go here, again this position, then down here, and then finally it came here. But in the next process, it will start from this and keep on doing the same thing. So here, then here, came down. So here, from here, it will stay there. Kind of understood what we need to do for each cell. For each cell, suppose there is a round stone there, we need to find out the position for its upper boundary, left boundary, down boundary, and right boundary. That means if the shift happens in that direction, what will be the final position of this cell ij for those four directions. And this will give us a graph which some looks like, but I'm still thinking of going over all the iterations, right, which is not possible. Afterward, what is the total load on our support? If you know the final position of any cell ij is, let's say, xy, then that cell's contribution to the total load on the north support would simply be, let's say, this cells ends up somewhere here, then its contribution is simply 7, which is its row number. And I think only row number matters, because in the end we only need to find out in this assignment of row numbers from bottom to top, you only need to know what will be any cells. This cell will have what row number after some iterations. So in that case, the east and west movements don't matter. How many of these stones can we expect? Is still very large. So I'm still thinking of going through all of these iterations, which is 10 raised to 9, and multiplied by the number of those stones in this grid, which is still too much. If you look at it, So there is some cell, let's say index ij. First it needs to go up and left, and let's say down, then right. It is going to end up at this, let's say ci cj. And we can do one thing, we can always find out these positions. Say if this cell had to go somewhere in any of these four directions, where will it its final position for all the four directions? That we can pre-compute. If we know that, then we can simply perform the iteration for 10 raised to 9 times. We just need to change, let's say these are the four directions of up, right, left and down. Then for these many times we need to change ci cj to first it will be iuj, then again with for all of this l p r. These are the steps, and this will run in 10 raised to 9 times 4 times, what was that number of cells? This is the force. Next thing is to think if it like this. So there is some starting position. We want to go somewhere. There would be starting position from that cell. It would be somewhere else, taking us some path which we don't know, but it is constructed. So for each cell, but doesn't seem correct to me. What can we think of? Anything else that comes to my mind? Basically, we want to traverse this path, and each time we know which direction to take. Let's say we are at step 1, we know the direction is north. We are step 2, then it is west, then down, south. It is east, then okay, north, west, south. We just need to traverse this path and need to find out what is the new x coordinate. I mean, even y coordinate doesn't matter. We only need to know this value, and then the answer for contribution to the answer for this cell would be n minus this. Thing is, the path length currently is 10⁹. Length is 10⁹. Even if I had to memorize this, then I need to know the x, y, and path length. It's still not feasible. Does it always comes back to its original place after a while? Is that a possibility? We can go anywhere. Let's try to understand for a particular test case. But that won't prove it. I just want to know if it is possible. So this particular cell, it stays here first, then goes here, then here, then here. It should be here, I guess. Right. It is in this position, which is correct. Next, it will go again above. Okay, it's fine. This one stays in the loop, but it is just for that particular cell. Let's look at this one. Go here, then here. Here, then it will be here, up, left, down, right. So if this is the path, up, left, down, and again right, so it will go here, up, left, down, right, up, left, down, right, up, and left. Down means it will directly come here, down, and right nothing. So again up, left, down, right. Does it eventually finds itself in a cycle? I'm thinking of trying the brute force. 9. If we keep on tracing a particular cell's positions, and these corners are what that particular cell is stopping at. So it is stopping here, 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 and that's we are at particular. We know that we need to go in this direction, and this cell coordinates are xy, and we know that the north, west, south, east, and steps remaining. Let's say this goes somewhere, then it gets stuck in this loop. Then in that loop, we will have some direction for which this point was triggered, the x and y coordinates. So if we simulate this, and let's say we keep on doing this will perform, and let's say we are at this position, and then we found out that we are moving to this state, for which for each of them we will keep track of x, y, and direction that we were currently at, and this is visited. That means we will simply keep on going in this. Still seems very complex. Even after this, we will have some, say, t number of steps to cover, and we are at this position. So we can find out the length of this cycle. Say it is L. Then let's say there are t steps remaining. Then after t minus L, we will arrive at the same starting point, which was this one. So after if we are at this starting point of this loop, when there were t steps remaining, then after t minus L steps are remaining, we will still be at this. After t minus L steps, we will be again be presented here all the way up to t mod L, and then we need to do these remaining steps manually. But I still don't know whether what would be the length of this, or whether there would always be a cycle or not. That is my question. Let's try the part 15, day 15, part 1 before that. First row, find the set of doors surrounded with even more warning signs, and door must be the room that collects all the living thoughts. Okay, this is Not important. Before you begin, please be prepared to use the holiday ASCII casing string helper algorithm appendix 1a. The hash algorithm is a way to turn any string of characters into a single number in this range. To run the hash algorithm on a string, start with the current value of 0, then each character in the string starting from the beginning of an ASCII code for current character of the string. Increase the current value. Okay. Current value to itself multiplied by 17. Add, then multiply, and then mod. To find this current value is the output of the hash algorithm. So to find out this h72 multiplied by this divided 200 plus 65 whole multiplied by 17. Okay, understood. So the result of running the hash algorithm on the string hash is 52. No written line characters of the result of the running hash in each step in the initialization sequence. For example, the result of running the hash algorithm on each of the steps is as follows. Okay, in this example, I mean, what is equals? Is it saying that we need to take one sex ASCII value? Because no, it can be different. I think this is for part 2 something. In some of the results. We'll try day 14 afterwards. Create. Answer is 1320. The input is one line, right, as they said. String line. Solve for this particular input. Let's say for character chna hash. Let's say this is hash. It was hash equals to hash plus ASCII value multiplied by 17. I guess, right? Multiplied by 17 and hash 56. Okay, let's try this quickly. 0. Wow. This should be add, multiply, and mod. Are we taking the line correctly? Okay, right, I forgot to append the characters. Okay, let's try archer input. Run part 2. This looks complicated. Oh, you convince the render to bring you the page. The page confirms that your hash algorithm is working. The book goes on to describe a series of 256 boxes numbered 0 to 255. The boxes are arranged in a line starting from the point where light enters the facility. The boxes have holes that allow light to pass from one box to the next all the way down the line. Inside each box there are several lens slots that will keep a lens correctly positioned to focus light motion through the box. The side of each box has a panel that opens to allow you to insert or remove lenses as necessary. As long as the wall running parallel, as long as the along the wall running parallel to the boxes is a large library containing lenses organized a focal length ranging from 1 through 9. The India also brings you a small handheld label printer. The book goes on to explain how to perform each step in the initialization sequence of process. It calls the holiday as case string helper manual arrangement procedure or HMAP for short. Each step begins with a sequence of letters that indicate the label of the lens on which the step operates. The result of running the hash algorithm on the label indicates that correct box for that step. The label will be immediately followed by a character that indicates the operation to perform. Either an equals or a dash. If the operation character is a dash, go to the relevant blocks and remove the lens with the key on label. If it is present in the box, then move any remaining lenses as far forward in the box as they can go without changing their order. Filling any space. If no that's in the box is the key on label, nothing happens. If the operation character is an equal sign, dash equals it will equal number and that needs to go into the relevant box. This will remove a lens and this will add a lens. Be sure to use a label marker to mark the lens with the label given in the beginning of the step so that you can find it later. There are two possible situations. If there is already a lens in the box with the same label, place on a new lens, remove the old lens and put new lens and it's not moving any other lenses in the box. Okay, if there is not already a lens in the box with the same label, add the lens to the box immediately behind the lens and the lens is already in the box. Add the lens to the box immediately behind any lens is already in the box. Wow, don't know of any of the other lenses. Current lens in the box, the new lens goes all the way to the front of the box. Here is the content of the box after each step in the example. Rn what? Okay, so this dash and equals and followed by a number. So string followed by equal or hyphen, then by a number for equals query box 0 by number focal length of the length that needs to go into the relevant box. What do you mean by relevant box? CM minus. Okay, this indicate the label of the lens on which the step operates. It asks to remove CM, but we don't have any CM. Then it says to add 3 in QP. It added. Then it said to add said to add CM. But what is this to? Focal and to point to the event box. All the way to the front of the box. Since we are modding it for 256, I think they are taking the mod value for this. I guess. Right. That's the result. Each step begins with a sequence of letters that indicate the level of the events on which this type operates. The result of running the hash algorithm on the correct box for that step. The label will be immediately followed by a character that indicates the operation to perform either an equal sign or a dash. Okay, the result of running the hash algorithm on the label indicates the correct box for that step. So we found out that Rn has hash 0, so it will add this value in that box. Then afterwards we say that CM has something, but I mean we still add Rn in that, right? Then QP will have, let's say, hash 1 and it is added. Then CM is hash, I don't know what its hash is, but I hope it is 0. And adding a value here, QP has hash 1, hence we will remove this in this step, so that this is from the previous step is removed. QP minus, then PC, hash is 4, fine, OT 9 is added, EB added, PC minus, but PC was in box 3. Wait, this is where it gets tricky. PC minus removed this, and everything to the right of them are to the shifted to left. PC 6. Okay. 7. Whenever we are adding it in some existing thing, let's say PC4, right? It was added here. Then PC 49 was added, but this was added to the right of it, and this was also added to the right of that row. This was removed, and this was again added to the right. But this was added to the left. No, it was not added, it was updated with this value. So earlier it was 9, it was made 7. Okay, let's read the rules again and we can start with the implementation. Put the lens, remove the lens, then move any lenses as far out in the box as they can. Go without changing the order, filling the space between nothing happens. Equals and it will follow by a number indicating focal length. Okay. Be sure to use the label marker to mark the lens. The label given in the beginning of the step so you can find it later. There is already the same label. Replace the old label with a new label. Remove the old lens. Okay, if there is not already a lens in the box with the same label, add the lens to the box immediately behind. Fine. I mean, this is simply update operation if it is present, or push back in this list, right? So this case means adding the right, which is pushed back. AB is again pushed back. Then this is removed, which is removing of this. This is 6. Then appending. Then OT7. Since this was already present, we just update this 9 with the 7. Fine. No relation whatsoever with the. Okay. The books that contain any lenses are shown. Within each box, lenses are listed from front to back. Each 1 plus the box number of the lens in the question. The slot number of the lens within the box. Data lenses Rn is in box 0. So what? They try to unnecessarily make this complicated. Focusing on box times position. 1 time 1. I mean, what 1? We just multiply 1 based box index with 1 based index of this item in this list and the value, and some of them. Okay, let's do this. The line, then let's call it hash. Okay, fine. We want to maintain vector of, let's say, pair of string to int. Would that work? And it has 256 boxes. Let's go terminate this. Let's say get hash is this function. I want to extract one more thing, which is everything before the equals and after the equals. It is of different length, so let's write a solution for that. Let's say this will give the answer for that. So let's solve this current query. Solve string query. If query dot back is a, let's check in the query types, or it's fine, we can do it in place. So hyphen, then I want to do the remove operation on query dot substr from 0 of length query -1. Else I will find out these two values. If ch is n equals what was I trying to do? For I size of query of I is this, from id is I plus 1. I think this number is only, what do we call, so 1 to 9. I think they have mentioned it, so let me just take this as query dot substr on 0 of length query -2, and this will simply be query dot back, and I want the value, right? String to int does this work for character? No. String number is this, num plus equals to query dot back num, and add operation on this type and this value. Let's write remove operation operation. This takes in the the namings are very weird. What's that? Let's call it type only. Hash for this is, let's say, get hash, and this goes in that particular vector. To do that, I will go over all the type and value in that. Do we call that a of hsh, and I want to remove this, right? I will need the indexing. A of ssh dot first, no, of I dot first is a type, then to delete id is an and break. Let's set is -1 if it is not found. If found, we need to remove this index from that vector. So remove is present, or erase all a of, I don't know the syntax, let me google it. Vector erase that index. So a of says dot erase of dot begin plus tell id. Hope this is okay. In this case also we have two conditions. Don't need to delete it, but if it is found, we update it. So a of h of I dot second is that new value, and let's say we break from it in that case, or return from the function, else we add it, right? So a of hsh dot pushback make pair type and value. For this particular test, the answer is, do they use the same test case? What was it? RNOT. Okay. Yeah, we need to do this thing right. And the answer for this was 145. Why have I... There is no single answer for a particular query, so let me keep it like this and like this. For box ID in 256, I need to go over size of A of box ID, and for each of them have I initialized answer? Yep. Answer plus equals box ID plus 1 times A of box ID of, wait, it was index and that value should be second, and ID plus 1. Looks okay. Last test case 060530. Done. We are left with day 14 part 2. I will think on it for some time and then we can stop the stream. Nothing here. Okay. Remove in one. These are the solutions for day 15, both parts. And I haven't committed the day 14 solutions yet. Part 1 is done, right? When these Python users do this very quickly, I basically have to write a lot of helper functions in C++. Cycles. What else can we do here? So if we have to go from any cell to any of the 4 directions, we will keep track of the counts of these stones until a hash is reached or a boundary is reached, and from there basically if we reach here and we have to find out the let's see, let's say this particular block wants to know its location while going down, so we start with count 1, then here it will be count 2, 3, 4, and now it reaches a boundary. So from this boundary, this is row number, what is it, n plus 1. So we have 4 of them, so fourth goes to n, third goes to n minus 1, minus 2, n minus 1, n minus 2, n minus 3. So it would be n minus count plus 1th row. I will put the link for this in the chat. So Advent of Code is basically 25-day challenge. In the month of December, each day a challenge is released, and we try those challenges on live stream. If I have to simulate this, let me check. First of all, let me count the number of rows in this. So I have this in the input, right? Cat test and cat test. Then I can grep for exact matches of this, I guess. No. But it is capital O. Okay, we got all of them, but we want exact. Grep count characters. Hundred. Okay, so we have 100 O's in this, and for each of them we will have to loop over a billion times. So for each of the starting cell I will check where it will end at after these many cycles. That's right. If brute doesn't work, then I will give up and try it afterwards. Okay. I don't need this. This is fine. Don't need. Taking the input, we create the matrix of characters. We initialize the number of rows and columns. Then we will see million times iterations, and we need to do this for all the cells for which it is a capital O. Let's say we find out its ending position. Let's say Ci Pj equals to, after performing this process from Ij, process takes in Ij, returns a pair of int to int. To do this for these many number of times. To do this for all of the 4 directions. So write the code for that first. Let's only do the thing that is important. So whenever we are going in up direction, row changes, so Ci changes, and respectively for down and left. Up, left, down and right. When you're going left, the column number changes. In right as well, column number changes. Let's check it for this particular test case after 3 cycles. Okay. I need up from, I also need the column number, right? Say column. This will go from row to row -1, row -2, and so on. And I also need to keep track of should I do this recursively or it's fine if it's -1, that means we went outside the matrix. So if we are somewhere here, count is initially 1, right? We started with this cell, we went on to this index which is -1. Now from that index plus the count, so the row number in which this cell should be row plus 1 and count should be fine because it is one based. And in case it is a hash, so this wants to go up, then count would be 1. When we reach here, hash was at this. Looks good to me. And the next case is either this is true or mat of row of column is a hash. Else we return get up of row -1. Column count will be incremented if that particular thing is a capital O. Okay, looks good. Let's do this for all the 4 directions. Starting screen key again. In this case, it will be row is n. Since we're using 0 based indexing, so this is what we should think of, right? Okay. And in this case, let's say we are here. We are at n. So n my row number minus the count. Get to be row number minus count. This should be plus. Rest is fine. Left and right. So for left, the column number changes. Whenever we are going to the left, column could become -1, or a blocker is found. This, in that case, we say it should be at column plus count. Left. In this case, column is the left. Let's do it for the right. Column could become M, or it is a blocker, and in that case it should be this thing. Hopefully it is correct. Now for up direction, row numbers in this will is get row only, right? Yep. No, get up from CICJ. Count is 1. Whenever we are going left, column number changes, so CJ changes. Whenever we are going left, whenever we are going down, CI changes. Right is CJ. Okay. Do one thing. I know that in the new matrix, this would be the positions. So I will create a copy of the original input matrix and update only those positions. I haven't returned their last value, so make pair CICJ. Perfect. Now I will update, but old positions would still be present, right? So let's do one thing. Let's make it character of result. And what was the length? This, let's say this is 500 by 500 for now. And I can do one thing here. I can initialize result of ij as a dot, and after to update the position of this particular thing, I will. This should be done before. Which is this thing. I want to print this again. What are they expecting in the answer? Okay, first let's print and check. ij new line, and it is the end of our flow. Okay, let us run it on sample. Doesn't look like the same sample, right? We have very less amounts of these. So what's the issue? Mm, input should be fine. N and M. Cij to Cicj. This 00 goes to 99. Is it correct? Let's check the result after each. No, we are not actually doing that, right? Hmm. In the final place, this is going at 9. Let's just check one thing. The state of all the cells after one iteration. Looks wrong. 00 goes to 63. Check. 00 goes to. How can it go to 63 after? No, it can go up, left. When it is coming down, it should be here. When it is going to the right, it should be here. 0, 1, 2, 3, 4. It should be 4, 5. Let's print something. For each of these cells, let's see where it goes in all the four directions. So we are looking at 0 0 when it goes up. Why does it return row 1? We're at this row, then we'll go at -1, and -1 the count would be, oh right, I think the count should be 0 at first. Right. So because if I'm at that state, I'm already considering the count say 1, then in the next state the count will become 2, and it would be 1 extra thing each time. So let's check it once again. 0 0 will be 0, 0 would be 1. I want to check for these, which are 0, 3 0 and 5 0, which would be here. 3 0 will go at index 2, correct, and 5 0 should go at index 3. 5 0. I think something broke. Okay, something is breaking in between. Is it only when I'm printing this, or This count should be positive here. Let's see if there is any issue. Count is greater than 0 in okay, I sort of understand what is happening. So once a cycle is completed, the locations of these would be changed, right? So we need to, and if they are changed, then in the next iteration or for these 4 steps, it is still referring to the original matrix, but that won't always happen. So let's say this O goes to this here, and now it says count where this cell will go from to the left or right, and there would be 0 number of O's in that direction. So what I have to do is I will memorize the answers. The first time they are found out, I only need to know what is the location of this cell to the other cell. I will have to think on this more. I can resume solving this tomorrow again, maybe, if I find anything helpful. I'm not completing the parts that I'm not able to solve, so part 2s are still remaining, 40, 10 and day 14. So if I encounter anything about the solution or some idea, I will resume. That's it for this today. Thank you.